Hello, good morning. Today, today I will present the power triangle of AC circuits. To understand where this power triangle comes from, first I will give an introduction about circuits. In DC circuits, the power delivered to a load is the product of the applied voltage and resulting current. So, it can be represented in this equation. P equals VI, where the unit is W. In AC network, V and I are sinusoidal quantities. So the equation representation is V equals the voltage magnitude sine of omega t plus theta, and for the current, this is instantaneous current, is equals to current magnitude sine omega t, where that omega is equals to 2 pi f. As instantaneous power is constantly changing, the real power is given as P equals V times I cosine theta. Consider this circuit. Let's take a look at this simple example that has a resistor, an inductor connected in series. Here we can look up at three voltages. So the voltage across the resistor, the voltage across the inductor, and the total voltage. Remember that the voltage in this circuit is in vector form. The reason of it, because we are dealing in AC voltage that has magnitude and phase shift. So, from Kirchhoff's voltage law or KVL, the relationship between the voltage is the total voltages equal to the voltage across the resistor plus the voltage across the inductor. So it means the voltage in this resistor is real and the voltage in the inductor is imaginary. When we draw this out in vector form, we have the voltage across the resistor in real direction. We have the voltage across the inductor in imaginary direction, and the sum of these two vectors is the total voltage. Okay. Also, we are aware that voltage is equal to current times the resistance, or current times the resistance in inductance. Then if we want to get the power, so our power will be, for that real direction, will be P equals I squared times R. For imaginary direction, our Q will be Q equals I squared times X sub L. So the total of these two power, which is our S, or the apparent power, is S equals V total times I. So it means a power triangle is used in determining the relationship among real or average. That is our P. And reactive and reactive, that is our Q, and apparent power is S in the AC circuit, where it can be represented either of these two diagrams. For inductive lobes, this one, and for capacitive lobes, for this one. So, in particular, that voltage and current include the following possibilities. Either, if our load is purely resistive, then the theta will be 0 degrees. In inductive load, if purely inductive load, our theta is equals to 90 degrees. And purely capacitive load, our theta will be negative 90 degrees. Those AC network that is primarily inductive, the theta is positive. So it means the voltage leads the current. For AC network that is primarily capacitive, our theta, or that angle, is negative. So I leads the voltage, or current leads the voltage. There are three quantities can be related in vector domain. So this is the three quantities, the S apparent, the P or real power, plus Q, which is the imaginary or VAR. So for P, it is equals to angle of 0 degrees. For inductive load, for this imaginary, if that one is inductive, then it is our angle will be 90 degrees. And if this one is capacitive, our angle will be negative 90 degrees. So for inductive load, the power is defined with this equation. S equals P plus that imaginary Q sub L. So our unit will be VA. So this is the corresponding diagram for inductive load. For capacitive load, the parent is defined as S equals P minus that imaginary Q sub C. So the only difference is that Q is in negative form. So this is the corresponding diagram. In case the network has both capacitive and inductive elements, the reactive component of the power triangle will be determined by the difference between the reactive power delivered to each. So it means if this is our reactive power is in positive side, it means you have the lagging power factor. And if it is in negative side, that is a capacitive load, you have a leading power factor. Consider this first problem number 1. We have the resistor and inductor connected in series, and our supply voltage is 100 volts with the angle of 0 degrees. So find the apparent power, real power, and the reactive power, including the power factor. So for our solution, first we need to solve the current. So I equals V over the total impedance, or C sub T. So it is equals to 100 the angle of 0 degrees over, for the total impedance is 10 ohms because this is series, plus the imaginary of 5 ohms. So as we observe for these two, we have the polar form and the rectangular form. So it should be the same before we can solve this equation. So this is equals to 100, the angle of 0 degrees, divide by, once we convert this rectangular form to polar form, it is 11.18, the angle of 26.56 degrees. So this is equals to 8.944 ampere, the angle of negative 26.56 degrees. So in order to solve the apparent power, apparent is voltage times our current. So our voltage is 100 volts, the angle of 0 degrees, times the current of 8.944 for that angle of 26.56 degrees. that is equals to 898.4. Our unit is BE, and the angle of 26.56 degrees. So this polar form can be converted to rectangular form, that is equals to 803.55 plus J, that is our imaginary number, J 401.71. Since, as we remember, S equals P plus that imaginary Q, JQ. So the real power is, this is our real power, the 803.55 watts. So if we will draw that one in vector, so in the trial direction, this is our P equals 803.55. As we know, this is our S, the 898.4, or VE, or our apparent power. And this is our Q, the 401.71. So our Q will be 401.71 VER. So our power factor can be solved like the cosine of 26.56. So equals to 0.89. It is lagging because our Q is positive. This is our power factor, equals 0.89. So next example for problem number 2. Consider this circuit in the series parallel. So we have the 30 ohms series with the 10 ohms connected with the inductor and series in 10 ohms, and this two is connected with parallel with our inductance capacitance of 20 ohms. So find the apparent power, real power, reactive power, and the power factor. So first we will need to solve the current. So our current will be I equals B over the total impedance. So this is equals to 100 volts over, because this two is series, so it means series parallel. So 1 over the minus J20, the imaginary number of 20 ohms for the inductance capacitance, plus 1 over 30 plus J10 ohms. Of course, this polar form will be converted to rectangular. This rectangular will be converted to polar form. So 100 with the degrees of 0 degrees over, so this one I directly solve, so 12 minus G16. So take a note, example, if you have a scientific calculator, in order to directly solve this one, scientific calculator is giving the option that you can convert from polar to rectangular or vice versa. So once converted to 100 for the angle 0 degrees over 20 and the angle of negative 53.13. So our total current is 5 ampere and the angle of 53.13 degrees. So for our power, that is A equals B times I. So 100 volts, an angle of 0 degrees times the 5 ampere, an angle of negative 53.13. So Our apparent power, or S, is 500 VA with the angle of negative 53.13. So once it will be converted to rectangular form, this is 300 minus G for 400. So as we know that S equals P plus GQ, or for the inductive, or S equals P minus GQ for the capacitive. So the real power is the 300 watts. So this is in the breakdown form. On our S, the apparent power is 500 VA. So our reactive power is, our Q is negative 400 VAR. So the power factor is equals to cosine of 53.13, that is 0.60 leading. So leading because this is negative, our Q is negative. So let's take a brief review. So the three elements of electrical power, real power, reactive power, and apparent power in AC circuit can be represented by three sides of triangle. Now this is called the power triangle. So the real power is measured in the units of watts. It is an adjacent side, defines the power consumed by the resistive part of the circuit. It performs the real work within the electric circuit. So the reactive power, that is our Q. The measured unit is bar. It is on opposite side of the triangle. So the power absorbed and returned in load due to its reactive properties. So it does not perform any useful work. It is caused by the inductor and capacitor. The apparent power S is the total power in AC circuit. It is located in hypotenuse of the triangle, right triangle. It is measured in the unit of volt ampere. And also the power factor, that is the ratio of real power to apparent power. Generally expressed as either in decimal or percentage value. So the cosine of the resulting angle between the current and voltage. In practical circuits, power factor can be anywhere between 0 to 1. Between 0 and 1, depending on the passive components within the connected load. So for inductive load, our circuit is lagging. For capacitive load, our circuit is leading, and when the real power consumed equals the circuit apparent power, that is unity. So unity, you have the power factor of 1. High power factor is necessary in a transmission system, which reduces transmission loss and improve voltage regulation at the load. It is increased to make the motor run efficiently and avoid overheating. The lower the power factor, the inefficient the circuit is. So that's all. Thank you and have a nice day. For any question, you can contact me, and that's all. Have a nice day.